Today, I'm going to go through the electron transport chain. So you've got all these complexes. Complex 1, complex 2, you've got coenzyme Q, complex 3, cytochrome C, complex 4, ATP synthase. This is your intermembrane space of your mitochondria, outer membrane, and this is your inner membrane. Okay. So what happens is, from the TCA cycle and the glycolysis, we generate NADH and FADH2, which are electron carriers. Okay? And what happens is in complex 1 is NADH, a proton is removed, right? And an electron is taken away. And the electron, right? So you're going to get plus an electron. The electron is going to go to the complex, supercharge this complex 1, and allow it to pump H plus into the intermembrane space. So we just pumped using electrons from the NADH, we were able to pump H plus into the intermembrane space. Okay? And now, this electron is passed on to coenzyme Q, sorry. It's passed on to coenzyme Q. Okay? Good so far? Then, FADH2 is also releases protons and electrons. Sorry. Right? So what you're going to have is, you're going to have 2 H plus missing, and you have 2 electrons, right? These electrons from the complex 2 are sent off to coenzyme Q. So coenzyme Q currently has all the electrons. And what coenzyme Q does, it brings it to complex 3. Okay? And in complex 3, right, it's similar to complex 1, where the electron supercharges, these electrons supercharge complex 3, and complex 3 can act as a pump and pump H plus into the intermembrane space. Now, the intermembrane space is increasing, the concentration of H plus is increasing in the intermembrane space. Okay? And now, the electrons are passed on to cytochrome C. Okay? And then cytochrome C passes these electrons one more time to complex 4. And complex 4 can act as a pump as well, pumping H plus into the intermembrane space. So now we've got a lot of H plus within this space. Now what's important to know is, why doesn't it move? The reason is, this is impermeable to it. It needs some sort of channel, whereas the outer membrane is permeable to some compounds. Okay? But it doesn't want to leave the outer membrane. It wants to get into the inner mitochondrial matrix, right? It wants to get into the mitochondria. So it wants to go through the inner membrane. Okay? Now what's going to happen with these electrons continuing on that are still present in complex 4? We have to get rid of them, because if it can't continue building up. The chain needs to keep moving along. So what happens is, oxygen comes along and it acts as the final electron acceptor. It accepts the electrons. And it takes on 2H plus. Let me just balance this out. And you overall, oxygen plus electrons plus protons, you're going to get H2O. But oxygen is needed in order to continue the electron transport chain. It acts as the final electron acceptor. Okay? That's good, but we still got H plus in the intermembrane space. What do? There's something called an ATP. ATP synthase is a protein. It's going to act as a channel. And what this ATP synthase is going to do, it's going to pump H plus back across that inner membrane, and it's going to phosphorylate ADP. So it's going to generate ATP. Okay? So now we're generating ATP, which is good. This is aerobic respiration, right? Why? Because we need oxygen. Aerobic, we need oxygen, okay? Now this step, ATP synthase, right, where we are pumping H plus with its concentration gradient, is called chemiosmosis. Chemiosmosis is literally a process where H plus is moving down its concentration gradient, and as it's moving down its concentration gradient, it's generating ATP. Okay? That's called chemiosmosis. That's it for the electron transport chain.